Chapter 1, Lesson 4, going to look at some relations and implicitly defined functions. And you remember a relation is simply a set of domain values and the corresponding y values. And a function is a relation where each item or each element in the domain has exactly one range value that goes with it. Now, in order to determine an ordered pair, or if an ordered pair is part of a relation, is simply a matter of substituting in the x value and determining if the y value is produced using the function rule that's given to you. So it's quite simply, if you wanted to know, for instance, here we have an ordered, are any of these ordered pairs, a part of this relation? Well, we would simply substitute in the 1 for x and the 1 for y and see if we got a true statement. Doing that, we would get 7, which does not equal 5, so 1, 1 is not part of this relation defined by this function, or I'll get it, defined by this algebraic equation. Then we substitute in 4, -2, and do the same thing, and then 3 for x and -1 for y, and we determine that 3, -1 is the only ordered pair that actually is a part of this relation, which is defined by this algebraic expression. Okay, so in order to determine which ordered pair is in the relation expressed by the equation, we simply substitute in the values. So here we have x squared plus y squared is equal to 25. We would substitute in 5 for x, 1 for y, and determine if we got 25. Any ordered pair that gave us that would be an ordered pair which would be part of the relation. And in this situation, both 3 and 4, as well as 0 and -5, would both make this equation true. Therefore, both are part of the relation. So you can't stop when you get just one and go, okay, that's the one. You have to determine if any of them are, so you have to check all of them. So that's how you would determine if an ordered pair is part of a relation. Now, implicitly defined function. Implicit means something that's implied. It's not given or not told straightforward to you, but it's implied. And which means, or a definition, suggested or understood without being directly stated. So in this expression, for example, we have x squared plus y squared, which equals 4. Now, this is the equation for a circle, which is not a function, but because if you did a vertical line test on the circle, it would intersect the circle in more than one place. Therefore, the function or the relation here is not a function. However, if we solve this equation for y, we can actually get two functions that are implied by this relationship that's given. So if we solve for y, we actually get y is equal to plus or minus the square root of 4 minus x squared, which both are functions, meaning we have y equals the positive 4 minus x squared, which in most cases, or in this case would be half a circle, which does pass the vertical line test. And you also have y equals the opposite of square root of 4 minus x squared, which would be the bottom half of the circle. So if we solve for y, we can actually determine two function equations which are implied or within this relationship, which we don't see directly, but if we solve for y, we can determine what the functions are, or some implicitly defined functions within the relation. So for problems like this, we're simply going to take an expression, solve it for y, and see if any implicitly defined functions are revealed by doing that. Okay, so let's take a situation like this. So here's x plus y squared is equal to 25. What are the functions, or the implicitly defined functions, given by this relation? So we're going to simply solve this equation for y. So we're going to move x to the other side, and then we're going to take the square root. So we're going to have y is equal to the square root of 25 minus x, and y is also equal to the opposite of the square root of 25 minus x, or you could put a plus or minus in front. So these two equations are equations of functions implied by the relation that's given. So this would be plus or minus the square root of 25. I don't know if you can see that, but there you go. All right, so let me do one more just to give you a quick idea of what these, how to do these. So here we have one, the absolute value, and this is a good one to review. So we're going to get the y by itself. The absolute value of y is equal to 1 minus x. And if you don't remember, when we have the absolute value of y, this actually creates two equations. y is equal to 1 minus x. That's one equation. And then y is equal to the opposite of 1 minus x. Because you remember, absolute value means the distance from 0. This 1 minus x represents the distance from 0. Well, I could go 1 minus x this way, which would give me a different distance of whatever that is. But I could also go this way, 1 minus x, which is the opposite direction. So that's where these two expressions come from. So y is equal to 1 minus x would be one function. Y is equal to the opposite of 1 minus x would be the other function. So we would have this, or y is equal to x, x minus 1 would be the other expression or function that's implied by this relation here. So y is equal to 1 minus x, and y is equal to x minus 1. So when you're doing with absolute value, you can get those. All right. So that's how to determine, or that is how to determine implicit functions that are within a relation. Solve for y, and that will give you the two functions.